In this question, we're given a universal dataset, which is denoted by the symbol over here. And we're told that in this dataset contains every odd number that's less than 30. We're also given set A and set B. A contains the numbers 3, 9, 15, 21 and 27, and B contains 5, 15 and 25. And in part A, we're asked to complete the Venn diagram to represent this information. So the first thing that we can do is to label our Venn diagram. We'll call this circle A, and we'll call this circle B. So now let's take a look at what these parts of the Venn diagram mean. So we can say that the numbers in set A will fall within this blue circle, which represents A. And now we can also say that the values in set B will fall within the pink circle, which represents B. But now what about the part in the middle, where they intersect? So the yellow area in the middle is a point of intersection between A and B. And inside this area of intersection will be any value that falls in both A and B. And so given the values in the question, let's begin to fill in our Venn diagram. We'll start with set A. We're told that the number 3 falls in set A. Looking at set B, we can see that 3 does not fall in set B, and so 3 is only in set A, which we can write in the blue circle. Then we have the number 9. Again, we can see that this is only in set A and not set B, so we can write this again in the blue circle that represents just the part for A alone. Then we have 15. Looking at the number 15, we can see that it's in set A, and taking a look at set B, we can see that it's also in set B. Since 15 is a shared value between set A and set B, we can say that 15 is a part of set A and set B, and so 15 will fall within the intersection of A and B, which is in the yellow shaded area in our diagram. Next we have 21 and 27. Neither 21 nor 27 are in set B, they're only in set A, and so we can fill in these values in the circle for set A on our diagram. Now looking at set B, we've already completed 15, and so we have 5 and 25 remaining. 5 and 25 are only in set B and are not in set A, which means we can write this in set B. But although we've completed both set A and set B, we haven't quite completed this question. We're told that the dataset is all odd numbers less than 30. And so this means that the odd numbers less than 30 that are not in set A, nor are they in set B, will fall outside of the circles in the Venn diagram. The odd numbers that are less than 30 that are not in set A, nor are they in set B, will fall within the green box, but outside of the circles A and B. Now let's think about all the odd numbers less than 30. The number 1 is not in set A or in set B, but it's still an odd number less than 30, so we can place it in the box here. Now the number 3 is already in set A, the number 5 is already in set B, 7 is not included in A or B, so it will also fall outside of the circles. Number 9 is in set A, number 11 is not included in A or B, so this will fall outside of the circles. 13 will also fall outside of the circles since it's not in A or B. 15 is in A and in B. 17 is not included in set A or set B, and so 17 will also fall outside of the circles. So will 19. 21 is in set A, so it won't fall outside of the circles. Then we have 23, which isn't in set A or set B, so it will also fall outside of the circles. Now 25 is in set B, 27 is in set A, and the final odd number less than 30 is the number 29, which isn't in set A, nor is it in set B, and so 29 will also fall outside of the two circles. Part A is worth 4 marks, so let's take a look at where these marks are allocated. Now the first mark is for labelling the Venn diagram correctly. We label the circles A and B, which will allow us to get the first mark for this question. Now the second mark is for having only the number 15 within the intersection, which we've clearly shown in our diagram. And now the third mark is for having the values 3, 9, 21 and 27 in the circle for A, or for having the values 5 and 25 in the circles for B. And now we've done both, which will allow us to get that third mark. And finally, that fourth mark is for getting every single odd number less than 30 that are not included in set A or set B, and including them outside of the circles in the Venn diagram. And now, since each number in the universal dataset of odd numbers less than 30 are all in the correct place, we've achieved the 4 marks needed to get full marks on part A. We're now told that a number is chosen at random from the universal sets, and in part B, we're asked to find the probability that the number is in the set A or B. Now, looking at our diagram, we need to find the number of values that are in either set A or in set B, and this includes the intersection. So we'll see we have the number 3, 9, 21, 27, 15, 5, and 25. All of these numbers fall within the set A or the set B, and the numbers outside of the circles don't count because they're in neither set A nor set B. And so, counting the number of values which are in set A or set B, we can see that there are 7 values. And we have a denominator of 15, since we have 15 values in total. And now 7 over 15 is in its simplest form. We can't simplify it any further. And so we can say that the probability that the number is in set A or B is equal to 7 over 15. Now part B is worth 2 marks. The first mark is for getting a numerator of 7, and the second mark is for getting a denominator of 15, allowing us to get full marks by getting an answer of 7 over 15. In this question, we're asked to solve the simultaneous equations 3x plus y equals minus 4 and 3x minus 4y equals 6. We can start by labelling this equation. We'll have equation 1 and we'll have equation 2. So now, looking at equation 1, what we can now do is make y the subject of this equation by bringing the 3x to the other side. And so, taking 3x away from both sides, we have y is equal to minus 4 minus 3x. And we need to keep this in mind for later in the question. Now, looking at equation 2, we have 3x minus 4y is equal to 6. And we found out that y is equal to minus 4 minus 3x. And so what we can do, we can say 3x minus 4y, but y is equal to minus 4 minus 3x is equal to 6. And we can now simplify this by multiplying minus 4 by minus 4 minus 3x. So we'll have 3x, and the minus 4 multiplied by minus 4 is equal to positive 16. Then we have minus 4 multiplied by minus 3x, which will give us positive 12x. And that's equal to 6. Now, collecting like terms, 3x plus 12x equals 15x, plus 16 equals 6. What we can now do is move the 16 over to the other side, and so taking 16 away from each side, we have 15x is equal to minus 10. And now to find x, we need to divide both sides by 15. And so minus 10 divided by 15 is minus 10 over 15, and so we end up with x is equal to minus 10 over 15. We've now found the value of x, so we can substitute this value in to either of the equations above in order to find the value of y. So let's substitute our value of x back into equation 1. With equation 1, we have 3x plus y equals minus 4, and as we said earlier, y equals minus 4 minus 3x. Since we found out that x is equal to minus 10 over 15, we can say that y is equal to minus 4 minus 3 multiplied by minus 10 over 15. And so expanding the brackets, we have minus 4, and then minus 3 multiplied by minus 10 over 15 is plus 30 over 15. Now 30 over 15 is the same as saying 30 divided by 15, which is equal to 2. So y is equal to minus 4 plus 2, and so y is equal to minus 2. So we've now found that x is equal to minus 10 over 15, and y is equal to minus 2. We can simplify the value of x by dividing both the numerator and the denominator by 5, and so we'll end up with x is equal to minus 2 over 3, and y is equal to minus 2. This question is worth 3 marks, so let's take a look at where these marks are allocated. The first mark is for eliminating one variable, x or y, and finding its value. So we started by eliminating the value of x, and we therefore found that x is equal to minus 10 over 15. which will allow us to get that first mark. And now the second mark is for using this found value and substituting this in to either of the equations above in order to find the other variable. So by finding the value of x, which is equal to minus 10 over 15, we were able to substitute this back into equation 1 and find that y is equal to minus 2. And finally, that third and final mark is for clearly stating the answers that x is equal to minus 2 over 3 and y is equal to minus 2, allowing us to get full marks for this question. In this question, we're given a table which shows some information about the dress size of 25 women, and in part A, we're asked to find the median dress size. And so we can say that the median position is found by n plus 1 divided by 2, where n is the sample size of the population. In this question, n is equal to 25, and so we can say that the median position is given by 25 plus 1 divided by 2, which is 26 over 2, which is equal to 13. And so we're looking for the 13th position. Now looking at our table, we can see that the number of women with a dress size of 8 is 2. And then the number of women with a dress size of 10 is 9. And then 2 plus 9 is equal to 11. And so currently, the number of women with a dress size of 8 or 10 is equal to 11. And then adding on 8 for the number of women with a dress size of 12, we can see that 11 plus 8 is equal to 19. And so we can see that the 13th position will be found with a dress size of 12. And we can therefore say that the median dress size in this population is equal to 12. We're now told that 3 of the 25 women have a shoe size of 7. Zoe says that if you choose a random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9 over 25, because 3 over 25 plus 6 over 25 is equal to 9 over 25. In part B, we're asked to find out whether or not Zoe is correct, and we must give a reason for our answer. First, let's take a look at where she gets her fractions from. We have 3 over 25, and since we're told that 3 of the 25 women have a shoe size of 7, 3 over 25 represents the fraction of women who will have a shoe size of 7. Now looking back at our table, we can see that the number of women with a dress size of 14 is equal to 6. And so looking at our fraction, 6 over 25, we can see that this fraction represents the probability of a woman having a dress size of 14. So we can see that Zoe has used the correct probabilities because she's talking about the probability that a woman has either a shoe size of 7 or a dress size of 14. But does that mean she's correct? In Zoe's calculation, she does the probability of the shoe size being 7 plus the probability of the dress size being 14. And now Zoe assumes that these two events are mutually exclusive. But this doesn't necessarily have to be the case, because a woman can have a shoe size of 7 and also be a dress size of 14 at the same time. And so we can now see that by Zoe adding these two fractions together, she assumed that the events are mutually exclusive, and this may not always be the case. And so we can say that Zoe is incorrect. And so we've now written that Zoe is not correct because a person can be in both categories at the same time, allowing us to get the mark needed for this question. In this question, we're told that Daniel bakes 420 cakes. He bakes only vanilla cakes, banana cakes, lemon cakes, and chocolate cakes. We're told that 2 out of 7 of the cakes are vanilla cakes, and that 35% of the cakes are banana cakes. The ratio of the number of lemon cakes to the number of chocolate cakes is 4 to 5, and we need to work out the number of lemon cakes that Daniel bakes. The first thing that we can do is to use the information given to us to find the number of vanilla cakes and the number of banana cakes. And so to find the number of vanilla cakes, we'll do 2/7 multiplied by the total number of cakes, which is 420, and we'll get an answer of 120 cakes. Now let's move on to finding the number of banana cakes that Daniel bakes. To find 35% of 420, we'll do 0.35 multiplied by 420, and then putting this into our calculator, we'll get an answer of 147 banana cakes. Now we're told that the ratio of the number of lemon cakes to the number of chocolate cakes is 4 to 5, and so we need to know the total number of lemon cakes and chocolate cakes. Since Daniel bakes only vanilla cakes, banana cakes, lemon cakes and chocolate cakes, we can use the fact that we've found out the number of vanilla cakes and banana cakes and take this away from the total number of cakes in order to find the number of lemon cakes and chocolate cakes. And out of the vanilla and banana cakes, the total is equal to 120 plus 147, which gives us an answer of 267. We can now say that the total number of lemon cakes and chocolate cakes is 420 take away 267, which gives an answer of 153. Now the question asks us to find the number of lemon cakes that Daniel bakes. And so the ratio of lemon to chocolate is equal to 4 to 5, and we have a total of 153. And so 4 plus 5 is equal to 9, which means we have 9 parts. 9 parts is equal to 153. And so to find 1 part, we need to divide both sides by 9. So 153 divided by 9 equals 17. Now looking back at our ratio, the lemon cakes to chocolate cakes is 4 to 5. Lemon has 4 parts. Since we found out that 1 part is equal to 17 cakes, 4 parts will be 17 multiplied by 4. And so we can say that the number of lemon cakes equals 17 multiplied by 4, which will give us an answer of 68 cakes. This question is worth 5 marks, so let's take a look at where these marks are allocated. Now the first mark is for using the fraction 2 over 7 to find the total number of vanilla cakes. We said that 2 over 7 multiplied by 420 equals 120, which gives us that first mark. Now the second mark is for finding the number of banana cakes by finding 35% of 420, and we found that there are 147 banana cakes. Now the third mark is using these two values in order to find the total number of lemon and chocolate cakes. So the total number of vanilla and banana cakes we found was 267, and we did 420 take away 267 to find that the total number of lemon and chocolate cakes is 153. The fourth mark is for using the ratio 4 to 5, and by using the fact that 9 parts is equal to 153, and so 1 part is equal to 17. And finally, that fifth and final mark is for getting a correct answer that the number of lemon cakes is equal to 68, allowing us to get the full 5 marks needed to attain full marks in this question. In this question, we're given a diagram, and we're told that AB, BC and CD are 3 sides of a regular polygon P. We need to show that polygon P is a hexagon. We can see in the diagram that we have a regular 12-sided polygon, and so we can use this fact in order to find its interior angle. And so to find the exterior angle of a regular polygon, we do 360 divided by the number of sides. And so we can say that the exterior angle of the regular 12-sided polygon is 360 divided by 12, which will give us an answer of 30 degrees. But we want to find the interior angle, and another fact that we need to know is the fact that interior and exterior angles add up to 180 degrees. And so we can say that the interior angle of the regular 12-sided polygon is 180 degrees take away 30 degrees, which will give us an answer of 150 degrees. And so we can label this on our diagram. Now we need to show that polygon P is a hexagon, and we can do this by finding its interior angle and comparing this to the value that it should be. And so we can now find out the interior angle of a hexagon. And we can do this by doing the same thing. We know that a hexagon has 6 sides. And like we said before, the exterior angle is 360 divided by the number of sides, so 360 divided by 6 will give us an answer of 60 degrees. And so the interior angle of a hexagon is 180 degrees take away 60 degrees, which is equal to 120 degrees. And so we need to prove that the interior angle of polygon P is equal to 120 degrees. We can see that this blue angle is the interior angle of polygon P. And we can use the fact that angles around a point equal 360 degrees in order to find out what this angle is. Since we're given a square, we know that the angle in the corner is 90 degrees. And so to find the blue angle, which we'll call x, we can do 360 take away 150 plus 90, which is the same as saying 360 take away 240, which will give us an answer of 120 degrees. And so we've now found that the interior angle of polygon P is equal to 120 degrees. Now comparing this to the value we found earlier, we said that the interior angle of a hexagon should be 120 degrees. Now since polygon P has an interior angle of 120 degrees, we've now proven that polygon P is a hexagon. And we can write this as a conclusive statement below. This question is worth 4 marks, so let's take a look at where these marks are allocated. Now the first mark is for finding the exterior or the interior angle size of the regular 12-sided polygon. We found out that the exterior angle of the 12-sided polygon is 30 degrees and its exterior angle is 150 degrees, and so that's our first mark. Now the second mark is for finding out what the interior or the exterior angle of a regular hexagon should be. And we found out that the exterior angle of a hexagon is 60 degrees and the interior angle is 120 degrees, which will give us that second mark. Now the third mark is for finding the interior angle of polygon P. We use the fact that angles around a point add up to 360 degrees, and we found that the interior angle of polygon P is 360 take away brackets 150 plus 90, which will give us an answer of 120 degrees. Now since we found that the interior angle of polygon P matches with what the interior angle of a hexagon should be, we were able to write a conclusive statement which will give us that fourth mark, saying that polygon P is a hexagon because it has an interior angle of size 120 degrees. Allowing us to get full marks for this question. In this question, we're told that the density of apple juice is 1.05 grams per centimetre cubed. We're told that the density of fruit syrup is 1.4 grams per centimetre cubed, and that the density of carbonated water is 0.99 grams per centimetre cubed. We're told that 25 centimetres cubed of apple juice is mixed with 15 centimetres cubed of fruit syrup and 280 centimetres cubed of carbonated water to make a drink with a total volume of 320 centimetres cubed. Now we need to find out the density of the drink, giving our answer correct to 2 decimal places. Now before we continue, the first thing that we need to do is to make sure that we know the formula for density. And density is given by the mass divided by its volume. Now we can start by finding the total mass of the drink. And we can do this by finding the mass of the apple juice in the drink, added with the mass of the fruit syrup in the drink, and added with the mass of the carbonated water in the drink. We're told that the density of apple juice is 1.05 grams per centimetre cubed. And now this means that for every 1.05 grams of apple juice, its volume is 1 centimetre cubed. Now we're told that 25 centimetre cubed of apple juice is in the drink. And so to get from 1 to 25, we have to multiply by 25. And so we can also do this on the other side to find the mass of apple juice in the drink. 1.05 multiplied by 25 will give 26.25 grams. And so we've found that there are 26.25 grams of apple juice in the drink. Now let's move on to finding the mass of fruit syrup in the drink. Since the density of fruit syrup is 1.4 grams per centimetre cubed, we know that for every 1.4 grams of fruit syrup, it has a volume of 1 centimetre cubed. Now the drink has 15 centimetre cubed of fruit syrup, and so to get from 1 to 15, we have to multiply by 15, and we can do the same on the other side. And 1.4 multiplied by 15 will give 21 grams of fruit syrup. And finally, we can move on to finding the mass of carbonated water in the drink. Since the density of carbonated water is 0.99 grams per centimetre cubed, we know that for every 0.99 grams of carbonated water, it has a volume of 1 centimetre cubed. And now the drink contains 280 centimetre cubed of carbonated water, and so we can multiply both sides by 280. And so 0.99 multiplied by 280 give 277.2 grams of carbonated water. Now that we've found the mass of the apple juice, the mass of the fruit syrup, and the mass of the carbonated water, we can find the total mass of the drink. And so we can say that the total mass of drink is 26.25 plus 21 plus 277.2, which will give us an answer of 324.45 grams. Now the question asks us to work out the density of the drink, and we're also told that the total volume of the drink is 320 centimetre cubed. And so now that we've found the mass and we're given the volume, we can use these pieces of information to find the density. We know that density is equal to the mass divided by the volume. And so in this scenario, we found out that the mass is 324.45, and we're told that the volume is 320 centimeter cubed. And so the mass divided by volume is 324.45 divided by 320, which is equal to 1.013906 ... and rounded to 2 decimal places is 1.01 grams per centimeter cubed. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. The first mark will be for finding the mass of the apple juice and the fruit syrup and the carbonated water. And so we found that the mass of the apple juice is 26.25 grams, the fruit syrup is 21 grams, and the carbonated water is 277.2 grams. And so finding these masses give us our first mark. Now the second mark is for finding the total mass of the drink by adding these values together and for getting an answer of 324.45 grams. Now the third mark is for a process to find the density of the drink by doing 324.45 divided by 320. And that fourth and final mark is for getting the correct answer of 1.01 grams per centimeter cubed, rounded correctly to 2 decimal places. In this question, we're told that triangle ABC is a right angle triangle, and we're asked to calculate the length of AB, giving our answer correct to 3 significant figures. So we can start by identifying AB on our diagram. We can see that AB is right over here. Now we're given the angle ACB, which is 23 degrees, and so given that angle, let's identify the opposite side, the adjacent side, and the hypotenuse. The hypotenuse is always the side opposite the right angle, which is the 15 centimeter line over here. Line AC is the hypotenuse, which we'll label as H. Now looking at 23 degrees, line CB is adjacent to this angle, and so we'll call the C adjacent side by labelling it A. And now line AB is opposite the 23 degree angle, and so we can say that line AB is the opposite, which we'll label as O. Now we'll be using trigonometric identities in this question, which means we need to use either sine, cos, or tan. We know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. We're asked to find length AB. Now we need to see which trigonometric identity has what we need. We have one known angle and one known side, and there's an unknown side length that we need to find. So we need to find the opposite side. We're given the hypotenuse, and we know the angle. So we can see that this trigonometric identity has to link opposite and hypotenuse together. And now we can correctly identify that this identity is sine, because sine is opposite over hypotenuse. And so we can say that sine 23 is equal to opposite over hypotenuse, which is equal to AB over 15. And we can now say that line AB equals 15 multiplied by sine 23, and we'll get an answer of 5.860966 ... We're asked to give our answer correct to 3 significant figures, and so we can say the line AB is equal to 5.86 centimeters to 3 significant figures. Now this question is worth 2 marks, so let's take a look at where these marks are allocated. The first mark is for writing down that sine 23 equals AB over 15, which we've clearly shown in our working. And the second and final mark is for getting the correct answer of 5.86 centimeters. In this question, we're told that a square with side length of x centimeters is inside a circle. Each vertex on the square is on the circumference of the circle. We're told that the area of the circle is 49 centimeters squared, and we need to work out the value of x, giving our answer correct to 3 significant figures. Now the first thing that we can do is to draw a diagram to represent this information. Now looking at the diagram, we can see that we have a square inside the circle, and each vertex lies on the circumference. We can also see that the side length of the square is equal to x centimeters. And we also know that the area of the circle is equal to 49 centimeters squared. Now to find the value of x, we can use Pythagoras. By joining the two opposite corners in our square, we can see that we now have the diameter of the circle. And we've now ended up with a right-angled triangle, which we can use to find x. Because we're given the area of the circle, we can find the length of the diameter. We know that the area is equal to pi r squared, and so we can say that 49 equals pi r squared, and so r squared is equal to 49 over pi, and therefore r is equal to root 49 over pi. And we should leave this in third form and in terms of pi for the time being. Now we know that the diameter is twice the radius, and so we can say that d equals 2r, which is equal to 2 multiplied by root 49 over pi, and so we have a diameter of 7.89865417 centimeters, and so we can label this on our diagram. Now let's use Pythagoras in order to find the value of x. Now in Pythagoras, we know that a squared plus b squared equals c squared, and so given our right-angled triangle, we can say that x squared plus x squared is equal to the diameter squared, which is 7.89865417 all squared. And using our calculator to find the diameter squared, we can say that 2x squared is equal to 62.3887369. We can now say that x squared, well, dividing both sides by 2, x squared is equal to 31.194368885. And finally, we can say that x is equal to the square root of 31.194 ... And so x is equal to 5.58519196, and giving our answer to three significant figures, we can say that x is equal to 5.59 centimeters. This question is worth 4 marks, so let's take a look at where these marks are allocated. Now the first mark is the use of pi r squared in order to find the diameter of the circle. We said that pi r squared equals 49, and we found that the diameter is equal to 7.89865417, giving us that first mark. Now that second mark is for setting up an equation using Pythagoras. We said that a squared plus b squared equals c squared, and so x squared plus x squared is equal to the diameter squared, which we set up over here. Now that third mark is for rearranging to find x squared is equal to 31.194368885. And that fourth and final mark is for square rooting to find the value of x and rounding this answer correctly to three significant figures, and so we found that x is equal to 5.59 centimeters, allowing us to get the full marks needed for this question. In this question, we're given a box plot which shows information about the distribution of the amounts of money spent by some male students on their holidays. In part A, we're asked to work out the interquartile range for the amount of money spent by these male students. And so to find the interquartile range, we need to do the upper quartile take away the lower quartile, and we can start by identifying these on our box plot. We know that this line on the left of the box represents the lower quartile, which we'll call Q1. The middle line represents the median, Q2, and the line at the edge of the box represents Q3, which is the upper quartile. We know that the line at the far end is the smallest point, and the line at the far right is the largest point. And so in part A, we need to find Q3 and Q1 in order to find out the interquartile range. And so we can start by finding the upper quartile by drawing a vertical line in order to see how much money was spent. Now following on from this line, we can see that the upper quartile is £330. And now let's do the same for the lower quartile. Following on from the line, we can see that the lower quartile is £150. And so we can say that the interquartile range is Q3 take away Q1, which is £330 take away £150, which will give us an answer of £180. Now part A is worth 2 marks. The first mark is for evidence of using both the upper quartile and the lower quartile, which we've clearly shown in our working by doing 330 take away 150. And now the second and final mark is for getting the correct answer of £180. Now in part B, we're told that the table below shows information about the distribution of the amounts of money spent by some female students on their holidays. And on the grid above, we need to draw a box plot for the information in the table. Now we've included a copy of the table from part B at the top, so we can see when we draw it on our graph. We can start by drawing the line for the smallest value, and the smallest value is 60. So now that we've drawn a line for the smallest value, which is £60, we can draw a line for the lower quartile of £180. And we can do the same thing for the median of £300. And now we'll do the upper quartile of £350. And the last line we'll draw is the largest value of £650. Now let's join these lines together. Now the lines for the lower quartile and the upper quartile meet and create a box. And then we'll join up the lines for the smallest value and the largest value. And now we'll label this female students. And so we've now drawn a fully correct box plot, allowing us to get the full 2 marks needed for part B. In part C, Chris says the box plots show that the female students spent more money than the male students, and we need to find out whether or not Chris is correct. So now taking a look at our box plots, we need to find the median of each box plot. So for the male students, the median is equal to £250. And for the female students, the median is £300. And so we can see that the median for the female students is greater than the median for the male students. And so we can therefore say that yes, Chris is correct, because the median for the female students is greater than the median for the male students. And so this correct answer will allow us to get the 1 mark needed to get full marks on part C. In this question, we're told that Naomi invests £6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of the 5 years, the investment is worth £8,029.35. We need to work out the value of X. Now with compound interest, we multiply the original value by the percentage multiplier to the power of the number of years that the interest is valid for. And so we have £6,000 interest for 5 years. And so we'll start with 6,000 multiplied, we'll call this y, to the power of 5. And y is our multiplier for our percentage. And then this is equal to £8,029.35. And so dividing 6,000 from both sides, we end up with y to the power of 5 is equal to 8,029.35 divided by 6,000, which is equal to 1.338225. And now to find y, we can do the 5th root of this value. And so the 5th root of 1.338225 is equal to 1.05999 ... We said that y represents the multiplier, and that's the percentage in decimal form plus 1. And so we can say that x plus 1 is equal to 1.05999. And so to find x, therefore, we'll take 1 away from both sides. And so we can say that x is equal to 0.05999 as a decimal. Now we're told that the investment gets a compound interest of X% per annum, which means we need the value of x as a percentage and not a decimal. And so 0.05999 is the same as saying 5.999%. We've rounded to one significant figure, we can say that the value of x is 6%. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. Now the first mark is for finding y to the power of 5 is equal to £8,029.35 divided by 6,000, which gives an answer of 1.338225. And now the second mark is for finding the 5th root of this value to find y, and identifying that this value is equal to x plus 1. And we found that x plus 1 is equal to 1.05999. Now the third and final mark is for finding that x is equal to 0.05999, and for writing this as a percentage of 6% rounded to one significant figure. In this question, we're told that Jeff is choosing a shrub and a rose tree for his garden. At the garden centre, there are 17 different types of shrubs and some rose trees. Now Jeff says that there are 215 different ways to choose one shrub and one rose tree, and we need to find out whether or not Jeff could be correct. And so the first thing that we can do is to say that the number of rose trees is equal to x. Now to find out how many different ways there are to choose one shrub and one rose tree, we'll do the number of shrubs multiplied by the number of rose trees. And so we can say that the number of shrubs multiplied by the number of rose trees, which is 17 multiplied by x, would be equal to 215. And we need to find out whether or not this is a possible combination. Now we can say that x is equal to 215 divided by 17, which will give us an answer of 12.647. Now we found that the number of rose trees is equal to 12.6, but it's not possible to have a decimal number of rose trees. The number must be a whole number. And so since 17 is not multiplied by a whole number to get 215, we can say that Jeff could not be correct, because it's not possible to have 215 different ways to choose one shrub and one rose tree. Now this question is worth 2 marks, so let's take a look at where these marks are allocated. Now the first mark is for an attempt to find the number of rose trees, which we found was equal to 12.6. And now the second mark is for using this value to prove that Jeff is incorrect because 12.6 is not a whole number, and you cannot have a decimal number of plants. And having this final conclusive statement at the end will allow us to get that second mark. In this question, we're told that the points A, B, C and D lie in order on a straight line. And now the ratio of AB to BD is 1 to 5, and the ratio of AC to CD is 7 to 11. We need to work out the ratio of AB to BC to CD. And now we can start by using multipliers. AB to BD has 6 parts, which is 1 plus 5, and AC to CD has 18 parts, which is 7 plus 11. And to get from 6 to 18, we need to multiply by 3. And so to make sure that these ratios are all on the same scale, we can multiply the ratio of AB to BD all by 3. And so we can now say that AB to BD equals 3 to 15, because we multiplied both parts by 3, and AC to CD is equal to 7 to 11. And now these are all on the same scale, which means we can use them interchangeably in order to solve our problem. Now we can start by representing the points A, B, C and D on a diagram. Now we can say that AB is equal to 3, because we found that AB to BD is 3 to 15, and so AB would be equal to 3. And now we can therefore say that BD is equal to 15. We know that AC to CD is 7 to 11, so we can say that AC is equal to 7, and that CD is equal to 11. Now we're trying to find the ratio of AB to BC to CD. Now we know that AB is 3 and CD is 11, and now we need to find BC. And so BC is this chunk over here. Now to find BC, we can do this entire chunk of 15, take away the chunk of 11, in order to be left with BC. And so we can now say that BC is equal to 15 take away 11, which is equal to 4. Now since we know that AB is equal to 3 and CD is equal to 11, we can say that the ratio of AB to BC to CD is equal to 3 to 4 to 11, which we can write in our answer box below. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. Now the first mark is for using multipliers to find that AB to BD is equal to 3 to 15. And because we now made both of the original ratios out of 18, we now made them comparable with each other. Now the second mark is for a process to find BC, which we said was equal to 4. And now the third and final mark was for getting the correct answer, that the ratio of AB to BC to CD is equal to 3 to 4 to 11, allowing us to get the full 3 marks needed for this question. In this question, we're asked to write down the 3 inequalities that define the shaded region. And so we can see that this shaded region is formed by 3 different lines. And so we'll call this line 1 in purple, we'll call the next line line 2 in green, and finally we'll call the last line line 3 in blue. And now we'll start by finding the equation of line 1. Now to find the equation of this straight line, we need to find its y-intercept and its gradient. Now we know that the gradient is equal to the change in y divided by the change in x. And so we can draw a triangle on line 1 to show this. Now on this triangle, we can see that the change in y is 1 take away minus 2, which is 3, and the change in x is 1 take away minus 2 again, which is equal to 3. Now we can say that for line 1, the gradient is the change in y divided by the change in x, which is equal to 3 divided by 3, which is equal to 1. And now we found that the gradient m is equal to 1. Now on line 1, we can see that the y-intercept is the origin, which is 0. And we can now also say that the y-intercept c is equal to 0. And now putting this together in an equation, we can say that y equals 1x, so just x, plus 0. So we'll leave it as y equals x. Now let's move on to line 2. And we can do the same thing by finding its gradients. And drawing a triangle on line 2, we can see that the change in y is equal to 2, and the change in x is equal to 4. Now for line 2, we can say that the gradient, the change in y, divided by the change in x, is equal to 2 divided by 4, which is equal to 0.5, and we find that the gradient is equal to 0.5. And now we need to find the y-intercept c. We can see that line 2 crosses the y-axis at the point 0, 1. Now since the y-intercept is equal to 1, we can say that c is equal to 1, and putting this together, we can say that y equals 0.5 x plus 1. And now finally, let's take a look at equation 3. Now with equation 3, we can see straight away that the gradient is 0, because it's a horizontal line with no slope, and so we can automatically say that m is equal to 0. And now looking at the y-intercept, we can see that the line 3 crosses the y-axis at the point 0, minus 2. And so we can now say that the y-intercept c is equal to minus 2. And now given that m equals 0 and c equals minus 2, we can put this together to form an equation for line 3, which is y equals minus 2. Now we need to find the inequalities that define the shaded region. Now with line 1, we can see that anything above line 1 falls in the shaded region. And so we'll also draw an upwards arrow via working out. Now with line 2, we can see that the shaded region is anything below line 2. And so we can draw a downwards arrow via annotations for line 2. And now finally for line 3, we can see that the shaded region falls above line 3. And so we can now have an upwards arrow by line 3. And now to write down the 3 inequalities that define the shaded region. So with line 1, we said that the shaded region is anything above the line y equals x. And so we can say that y is more than or equal to x. Now with line 2, we said that the shaded region falls within anything below the line y equals 0.5x plus 1. So we can say that y is less than or equal to 0.5x plus 1. And finally, line 3, we said that the shaded region falls anywhere above the line y equals minus 2. And so we can say that y is more than or equal to minus 2. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. Now the first mark is for finding the equation of the line y equals x. The second mark is for finding the equation of the line y equals 0.5x plus 1. And the third mark is for identifying the equation y equals minus 2. And now the fourth and final mark is for identifying whether these lines are less than or equal to, or greater than or equal to, and for stating the final inequalities that y is more than or equal to x, y is less than or equal to 0.5x plus 1, and y is more than or equal to minus 2, allowing us to get the fourth and final mark needed for this question. In part A, we are asked to simplify the fraction x squared minus 16, all divided by 2x squared minus 5x minus 12. Now we can start by factorising both the numerator and the denominator. Now recognising x squared minus 16 as a difference of two squares, we can factorise this as x plus 4 multiplied by x minus 4. Now as for the denominator, we can factorise this as 2x plus 3 all multiplied by x minus 4. And so we have x minus 4 on both the numerator and the denominator, and so these cancel each other out. And so we're left with x plus 4 divided by 2x plus 3, which is our final answer, and we can write this in our answer box below. Now in part B, we need to make v the subject of the formula w equals 15 brackets t minus 2v over v. Now the first thing that we can do is to multiply both sides by v. And so we end up with wv equals 15 brackets t minus 2v. Now we need to expand the brackets on the right hand side, and so we can say that wv equals 15t minus 30v. Now moving the minus 30v to the other side, we can say that wv plus 30v is equal to 15t. And since we want to make v the subject of the formula, we need to factorise v out of the left hand side. And so we can say that v brackets w plus 30 is equal to 15t. Now to find v, we need to divide both sides by w plus 30. And so we can now say that v is equal to 15t divided by w plus 30, which we can write in our answer box below. Now this question is worth a total of 6 marks. To get the 3 marks needed for part A, we get the first mark for factorising the numerator, the second mark for factorising the denominator, and the third mark for getting a final answer of x plus 4 divided by 2x plus 3. And now for the next 3 marks in part B, the first mark is for a correct step toward the solution. For example, expanding the brackets to get 15t minus 30v, or multiplying both sides by v. Now since we did both, that will get us that first mark. Now the second mark is for a method to rearrange the formula to isolate the terms in v, by doing wv plus 30v equals 15t. And so by isolating all the terms that have v in it to one side, we now get that second mark. And now the third mark in part B is for continuing this method and for getting a final answer of v is equal to 15t over w plus 30, allowing us to get the 6 full marks needed for part A and part B in this question. In this question, we are given a triangle ABC, and we're told that the area of triangle ABC is 6 root 2 meters squared. And now we need to calculate the value of x, giving our answer correct to 3 significant figures. Now we know that the area of a triangle is half AB sine C. Now we can label line AB as A, line CB as B, and the angle C as 45 degrees. Now we can use this formula in order to find the value of x. We're told that the area is 6 root 2, and so 6 root 2 is equal to half multiplied by A, which is 2x minus 1, multiplied by B, which is x plus 3, multiplied by sine C, which is sine 45. Now simplifying this further, we can say 6 root 2 equals half, and now to expand our double brackets, we'll do 2x multiplied by x, which will give us 2x squared. Then we have 2x multiplied by 3, which is 6x, then minus 1 multiplied by x, which is minus x, and so 6x minus x will leave us with 5x. And then we have minus 1 multiplied by 3, which is minus 3. And that all multiplied by sine 45, and knowing our trigonometric values, we can say that sine 45 is equal to root 2 over 2. Now we can simplify this again and say 6 root 2 equals 2x squared plus 5x minus 3, all multiplied by a half multiplied by root 2 over 2, which will give us root 2 over 4. Now dividing both sides by root 2 over 4. When we divide the left-hand side by root 2 over 4, we have 6 root 2 divided by root 2 over 4. And when we plug this into our calculator, we get an answer of 24. And then 2x squared plus 5x minus 3, all multiplied by root 2 over 4, divided by root 2 over 4, will simply leave us with 2x squared plus 5x minus 3. We can now say that 2x squared plus 5x minus 3 equals 24. And now bringing the 24 over to the other side, we can say that 2x squared plus 5x minus 27 is equal to 0. And now since we're left with a quadratic equation, we can use a quadratic formula to solve for x. We can say that x is equal to minus b plus minus root b squared minus 4ac over 2a. Now we can identify that a is equal to 2, b is equal to 5, and c is equal to minus 27. And so plugging this into our calculator, we're left with x is equal to 2.63104 ... or x is equal to minus 5.131043 ... Now since our value of x is referring to a length of a triangle, we know that the value of x cannot be negative, and so our answer is a positive value of x. We're asked to give our answer correct to 3 significant figures, and so we can say that our final answer is that x is equal to 2.63. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. The first mark is for setting up the expression 6 root 2 is equal to half multiplied by x plus 3 multiplied by 2x minus 1 multiplied by sine 45. Now the second mark is for expanding the brackets in the expression, and so we expanded 2x minus 1 multiplied by x plus 3 and for getting 2x squared plus 5x minus 3. Now the third mark is for the process to set up the equation and rearrange into the form ax squared plus bx plus c equals d, which we did when we ended up with 2x squared plus 5x minus 3 equals 24. Now the fourth mark is for rearranging to get a quadratic equation equal to 0 and for substituting these values into the quadratic formula in order to solve for x. Now the fifth and final mark is for getting the correct answer that x is equal to 2.63 rounded to 3 significant figures. In this question, we're told that x n plus 1 is equal to minus 2 minus 4 over xn all squared. And we start with the value x0 is equal to minus 2.5. In part A, we're asked to find the values of x1, x2, and x3. We'll start by finding x1 by substituting in the value of x0. So we'll say that x1 is equal to minus 2 minus 4 over minus 2.5 all squared. And when we put this into our calculator, we'll get that x1 is equal to minus 2.64. Now to find x2, we'll substitute the value of x1 into our equation, and we can say that x2 is equal to minus 2 minus 4 over minus 2.64 all squared. And when we put that into our calculator, we get an answer of minus 2.573921.028. Now to find x3, we can keep the value of x2 in our calculator and say that x3 is equal to minus 2 minus 4 over minus 2.57 ... all squared. And since we can keep this entire value of x2 in our calculator, we know that we'll get the most accurate answer for x3. And so putting this into our calculator, we'll now get an answer that x3 is equal to minus 2.6037672555. And now in our answer box, we can write down the values of x1, x2, and x3, and round each value to 3 significant figures. So we'll say that x1 is equal to minus 2.64, x2 is equal to minus 2.57 and x3 is equal to minus 2.60. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. The first mark is for substituting the value of x0, which is minus 2.5, into the equation in order to find that x1 is equal to minus 2.64. Now the second mark is for substituting in minus 2.64 into the equation to find x2, and then substituting minus 2.573 into the equation to find x3. And finally, the third mark is for getting the correct answers of x1, x2 and x3, all rounded to an appropriate degree of accuracy. In part B, we are asked to explain the relationship between the values of x1, x2 and x3 and the equation x cubed plus 2x squared plus 4 equals 0. Now the first thing that we can do is write down the iterative form of the equation as given to us in part A, and it said that xn plus 1 is equal to minus 2 minus 4 over xn all squared. Now let's see if we can multiply every term in the iterative form of the equation by x squared. Now for simplicity, let's say that xn plus 1 is equal to x, and x multiplied by x squared will give us x cubed. Then we have minus 2. Minus 2 multiplied by x squared will give us minus 2x squared. And finally, we'll say xn all squared for simplicity is equal to x squared, and so minus 4 over x squared multiplied by x squared will leave us with minus 4. So now we have the equation x cubed equals minus 2x squared minus 4, which we can see is now similar to the equation given to us in the question of part B, which says x cubed plus 2x squared plus 4 equals 0. And now we can get this equation by bringing the minus 2x squared and the minus 4 over to the other side. And so we can now say that x cubed plus 2x squared plus 4 is equal to 0. But we haven't yet answered the question explaining the relationship between the values of x1, x2 and x3 and the equation x cubed plus 2x squared plus 4 equals 0. And so the first thing that we can say is that x cubed plus 2x squared plus 4 equals 0 is a rearrangement of the iterative form given to us in part A. Now that we've said that x cubed plus 2x squared plus 4 equals 0 is a rearrangement of the iterative equation in part A, we can say that the relationship between the values of x1, x2 and x3 and the equation x cubed plus 2x squared plus 4 equals 0 is that the iterations are estimations of the solutions of x cubed plus 2x squared plus 4 equals 0, which we can write down in the answer box below. Now part B is worth 2 marks, so let's take a look at where these marks are allocated. Now the first mark is for stating the link between x cubed plus 2x squared plus 4 equals 0 and the iterative form given in part A. And so we said that x cubed plus 2x squared plus 4 equals 0 is a rearrangement of the iterative equation in part A, allowing us to get that first mark. And now the second mark is for clearly stating the relationship between the values of x1, x2 and x3 and the equation. And so we said that x1, x2 and x3 are estimations of the solutions to x cubed plus 2x squared plus 4 equals 0, allowing us to get the second mark needed for part B. In this question, we're told that a train travelled along a track in 110 minutes, correct to the nearest 5 minutes. Jake finds out that the track is 270 kilometres long, and he assumes that the track has been measured correct to the nearest 10 kilometres. And in part A, we are asked to find out whether or not the average speed of the train could have been greater than 160 kilometres per hour. Now the first thing that we need to know is that the average speed is equal to the distance divided by time. Now since we're asked whether or not the average speed of the train could have been greater than 160 kilometres per hour, we need to find the upper bound of the speed and see if the upper bound is more or less than 160. Now since speed is equal to distance over time, we can see that we're working with division. And in order to find the upper bound for division, we do the upper bound of the numerator divided by the lower bound of the denominator in order to get the greatest difference and therefore the greatest value of speed. Now since we have the distance in the numerator and the time in the denominator, let's first find the upper and lower bounds of these values. And so we'll start with distance. We have a distance of 270 kilometers, measured correct to the nearest 10 kilometers, and so the upper bound and lower bound of the distance, the lower bound will be 265, and the upper bound will be 275. Now we can do the same thing for the time. We have a value of 110 minutes, correct to the nearest 5 minutes. And so the upper and lower bounds, the lower bound will be 107.5, and the upper bound will be 112.5. Now we said that the upper bound of the speed is the upper bound of the numerator divided by the lower bound of the denominator. And so we can say that the max speed, the upper bound of the numerator is the upper bound of the distance, which is equal to 275, and the lower bound of the denominator is the lower bound of the time, which is 107.5. But this is where we need to be careful with our units. The speed is given in kilometers per hour. We have the distance in kilometers, but the time given in minutes, and we need to have the time in hours. And so what we can do, we'll continue with the upper bound of the distance, 275, divided by 107.5. Now to convert from minutes to hours, we divide by 60. And so we'll do 175 all divided by 60 in our denominator. And when we plug this value into our calculator, we'll get an answer that the max speed is equal to 153.488371. Now we're asked to find out whether or not the average speed of the train could have been greater than 160 km per hour. Since we found that the maximum speed is 153.5 km per hour, we know that the average speed of the train could not have been greater than 160 km per hour. And so we can write this down as a conclusive statement below. Now part A is worth 4 marks, so let's take a look at where these marks are allocated. Now the first mark is for a process to find both the upper and lower bounds for the distance and for the time, which we've shown clearly in our working. Now the second mark is for a process to find the speed by dividing the distance by the time. Now the third mark is for a process to work in consistent units of time, which we did when we did 107.5 divided by 60, so that the units for the time is in hours rather than minutes, allowing us to get that third mark. Now the fourth and final mark is for a conclusive statement, saying that no, the average speed of the train could not have been greater than 160 km per hour, because we found that the max speed is 153 km per hour, and this is less than 160, allowing us to get the full 4 marks needed for part A. Now in part B, we're told that Jake's assumption was wrong, and that the track was actually measured correct to the nearest 5 kilometers, and we need to explain how this could affect your decision in part A. So if the track was measured correct to the nearest 5 kilometers rather than correct to the nearest 10 kilometers, we'll have a smaller distance covered in the same amount of time. And so since we have a smaller distance, we can therefore say that the value for speed calculated in part A will decrease. And so we can write this down in our answer box below. So now we've said that less distance is covered in the same amount of time, and so the maximum speed calculated in part A will decrease, and this will allow us to get the 1 mark needed for part B. In this question, we're told that A, B and C are points on a circle of radius 5 cm and centre O. DA and DC are tangents to the circle, and DO is equal to 9 cm. We need to work out the length of arc ABC, giving our answer correct to 3 significant figures. So to work out the length of arc ABC, we need to first find this angle. Now we can start to find this angle by finding out the angle AOD and the angle COD. We're told that DA and DC are tangents to the circle, and we also know that an angle between the radius and a tangent is always equal to 90, and so we can say that angle OAD and angle OCD are both right angles. So now we have 2 right angle triangles. We know that the length DO is 9 cm, and so we can now use trigonometry to find the angles OAD and COD. Now we'll start with triangle AOD. We have a right angle triangle, and we're trying to find this angle, which we'll call X. We can say that the hypotenuse is length OD, and that the adjacent side to the angle is line AO. So the trigonometric identity that links adjacent and hypotenuse together is cosine, and so we can say that cos X is equal to adjacent over hypotenuse, which is equal to 5 over 9. And so we can say that angle x is equal to cos minus 1, 5 over 9, which will give us an answer of 56.2510114 degrees. Now triangles AOD and triangles LCD are identical, and so we can say that angle COD is also equal to x. Now we know that angles around a point are equal to 360 degrees, and we can use this in order to find the angle needed to find the length of arc ABC, and we'll call this angle y. And so given that angles around a point is equal to 360 degrees, we can say that the angle y is equal to 360 take away x plus x, which is 360 minus 2x, which is now equal to 360 minus 2 times 56.2510114. And so when we put this into our calculator, we will get an answer of y equals 247.4979772 degrees. Now that we found angle y, we can find the length of arc ABC. Now we know that the arc length is equal to theta over 360 multiplied by 2 pi r. Now theta represents the angle of the arc, and we found that the angle of the arc is angle y, which is equal to 247.4979772. So we can say that arc ABC is equal to 247.49 divided by 360, all multiplied by 2 times pi times the radius of 5. And now placing this entire equation in our calculator, we'll get an answer that the arc length is equal to 21.59827 centimeters. We're asked to give our answer correct to 3 significant figures, and so the length of arc ABC is equal to 21.6 centimeters. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. The first mark is for recognising the angle OAD and angle OCD are equal to 90 degrees, which we've shown in our diagram. And now the second mark is for using trigonometry to set up an equation for the angle DOA, which we called x. And so we said that cos x is equal to 5 over 9, giving us that second mark. Now the third mark is for using inverse trigonometry to find the angle x. And so we said that x is equal to cos minus 1, brackets 5 over 9, which is equal to 56.25 degrees. Now that fourth mark is for a complete process to find the arc length ABC. And so we'll get this fourth mark by saying arc length of ABC is 247.49 divided by 360, all multiplied by 2 times pi times 5. Now writing this down will give us that fourth mark. And finally, that fifth and final mark is for getting an answer of 21.6 centimeters, rounded correctly to 3 significant figures. And so we've now achieved the 5 marks needed to get full marks on this question. In this question, we're asked to solve the quadratic inequality 2x squared plus 3x minus 2 is more than 0. So the first thing that we can do is to factorise this equation. And so for the time being, we'll say that 2x squared plus 3x minus 2 is equal to 0, rather than greater than 0. And so when we factorise this, we'll get 2x minus 1, x plus 2 is equal to 0. Now we can solve to find the values of x. So 2x minus 1 equals 0. We'll say that 2x is equal to 1, so x is equal to a half. And then we have x plus 2 equals 0. And so bringing the 2 to the other side, we'll say that x is equal to minus 2. And so these are our two solutions. But that's for the equation 2x squared plus 3x minus 2 is equal to 0. But we need to solve the equation 2x squared plus 3x minus 2 is more than 0. And when we have a quadratic inequality, it's always useful to draw a diagram. And so we'll draw a quick sketch of 2x squared plus 3x minus 2 is equal to 0. So we have x is equal to a half, and we have x is equal to minus 2. The sketch doesn't need to be accurate, it will just show us how the diagram should look. 2x squared plus 3x minus 2 is more than 0. And so let's highlight the part of the graph that satisfied this. So we can now see that the highlighted parts represents any points where 2x squared plus 3x minus 2 is more than 0. And so we can see that to satisfy this equation, we need to have any point greater than a half and any point less than minus 2. Now since the points where 2x squared plus 3x minus 2 is greater than 0 is anything where x is less than minus 2 and x is greater than a half, we can solve this inequality by saying x is less than minus 2 and x is greater than a half. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. The first mark is for factorising 2x squared plus 3x minus 2 and for getting 2x minus 1 multiplied by x plus 2. Now the second mark is for finding the two solutions as minus 2 and a half. Now the third and final mark is for saying that x is less than minus 2 and x is more than a half, and so we were only able to do this by drawing a quick sketch of the diagram to see exactly what we're talking about when we say that 2x squared plus 3x minus 2 is more than 0. And so getting the final answer of x is less than minus 2 and x is greater than a half will give us that third and final mark needed to get full marks in this question. In part A, we are told that the equation of a curve is y equals a to the power of x, and point A is a point where the curve intersects the y-axis. We need to state the coordinates of A. And so in this question, there's no calculation involved, but there is a fact that we need to have memorised in order to be able to answer this question. And so any exponential graph in the form y equals a to the power of x, just like the one we've been given in this question, will cross the y-axis at the point 0, 1. Since A is the point where the curve intersects the y-axis, we can say that the coordinates of A is 0, 1. Now in part B, we're told that the equation of circle x is x squared plus y squared equals 16. The circle C is translated by the vector 3, 0 to give circle B, and we need to draw a sketch of circle B. We need to label the coordinates for the centre of circle B and any points of intersection with the x-axis. We can start by sketching circle C, so that we have an idea of what we're sketching for circle B. Now circle C has the equation x squared plus y squared equals 16. And so the equation of this circle is in the form x squared plus y squared equals r squared. And when we have an equation of a circle that's x squared plus y squared equals r squared, the centre of the circle is always 0, 0, which is the origin. Now we have r squared equals 16, and so the radius r is the square root of 16, which is equal to 4. Now we can draw a rough sketch of circle C. We know that the centre is origin, and that the circle has a radius of 4, which means the circle will cross the points 4, 0, 0 minus 4, minus 4, 0, and 0, 4. And so we can join these points together to form a circle of radius 4 with a centre at the origin. Now the circle doesn't have to be perfect because it's just a sketch. Now that we have a sketch of circle C, we can translate this circle by the vector 3, 0 to give circle B. Now when something is translated by the vector 3, 0, we can see that it moves 3 units to the right and it moves 0 units upwards. And so now we can see that circle B is a translation of circle C 3 units to the right, and it doesn't move upwards or downwards, so we only need to worry about moving it to the right. Now let's start to draw circle B, and we'll start with the centre. The centre of circle C was 0, 0, and we need to move this 3 units to the right. As so since we're moving horizontally, we can ignore the y coordinate because the y coordinate will stay the same. So now looking at the x coordinate 0, 3 units to the right means that we add the x coordinate by 3. And so where we had the coordinate 0, 0 for the centre of circle C, the centre of circle B will have the coordinate 3, 0. We can now move on to the points of intersection with the x-axis. And so with circle C, we have the points minus 4, 0 and 4, 0. And like we said earlier, the y coordinate does not change, because the vector 3, 0 is only a horizontal translation. And so minus 4, 0, we can focus on the x coordinate. X coordinate is minus 4, and shifting the 3 units to the right will be minus 4 plus 3, which is minus 1. And so the translated coordinate of minus 4, 0 is now equal to minus 1, 0. Then we have the point 4, 0. Now shifting this 3 units to the right, 4 plus 3 is equal to 7, and so we have the point 7, 0. Part B says that we need to draw a sketch of circle B and label with the coordinates the centre of circle B and any points of intersection with the x-axis. So we have the centre and both points where the circle crosses the x-axis. But even though we only asked for these 3 points, it's useful to draw the other 2 points so that we know exactly where we can draw a circle. So in circle C, we have the point 0, 4. So we ignore the y coordinate of 4 because this doesn't change. And we know that 0 shifts 3 units to the right, and so we have the new coordinate 3, 4. And then finally, we have the point 0, minus 4. Like we said before, we ignore the point minus 4 because that's the y coordinate which doesn't change, and 0 shifted 3 units to the right is 3. And so the new coordinate for 0 minus 4 will be 3 minus 4. So now that we have all the points for circle B, we can join this together. So we've now drawn circle B. Part B is worth 3 marks, so let's take a look at where these marks are allocated. The first mark is for drawing and labelling the centre of the circle, which is the point 3, 0. Now the second mark is for drawing the intersections on the x-axis at the points minus 1, 0 and 7, 0, and also drawing a circle of radius 4. Now we've done both of these, allowing us to get that second mark. And the third mark is for getting a fully correct answer for circle B, with the correct labels and the correct points. Now since our sketch of circle B is fully correct, we'll now get that third mark, needed to get full marks in part B.